Hello, everyone. Welcome to the Ansys Tips and Tricks webinar series. My name is Josh Soneby, and I will be the host for this webinar session. Today's session is on fluid dynamics, and the topic is Ansys Discovery Live, Fluid Simulation Tips and Tricks, presented by Brian Bueno, who is a Senior Technical Support Engineer. Everyone has been muted, and the webinar is being recorded. Questions can be submitted anytime during the presentation using the WebEx Q&A functionality. Time permitting, all questions will be addressed at the end of the presentation. I will now pass it over to you, Brian.
Thanks, Josh. Hello, everyone, and welcome to the first of our series of Discovery Live Tips and Tricks webinars. Today's webinar will be covering fluid simulation. So for those of you who are new to Discovery Live or haven't heard too much about it, let's first take a look at what exactly is Discovery Live. So Discovery Live is a new package that we've released fairly recently that provides you with instantaneous real-time simulation results. This is in contrast to the traditional solvers and traditional Ansys flagship products because it provides much faster results at the expense of a little bit of fidelity. So we're looking at solving or providing results in a matter of seconds as opposed to minutes or hours. And this is really intended to allow you to explore various different design concepts quickly and without sacrificing too much time. So the idea here is to be able to explore design concepts, make changes, and see those results as quickly as possible to help you in your design process. This will allow you to understand whether or not you're heading in the right direction, whether you should continue along the path that you're on now with the changes or modifications that you've decided on, or whether it's time to explore different options. So along with this, Discovery Live has various different physics available to you. You have solvers for fluid simulations, structural, modal, and thermal. So today we're going to be taking a look at a particular challenge, which is testing various conceptual designs. You have a lot of different possibilities, and you have to quickly decide upon which one is going to be the best option to go through. Determining that path in traditional solvers can take quite a bit of time. So you may end up spending hours waiting for results for one particular test, only to find out that there was something wrong with the design or maybe something was overlooked. And so that can cost time and really result in delays when the time to production is critical. Ideally, you want to be able to stay ahead of the competition, so Discovery Live is going to help you do that in a variety of different ways. For today's example, we'll be taking a look at one thing in particular, among others, but in particular, one of the most high-pressure, high-intensity areas of an industry is Formula One racing. And I thought this was a good example for the fluid simulation because in Formula One, you have constant evolution, so the designs of the car are constantly changing. In 2008, you can see an example here of a front wing on the Formula One car. That was back in 2008. We're now up to 2018, and the front wings are much, much more complex. So along with this constant evolution, you have a very limited window for design and testing. The actual on-track testing for these cars happens over the course of a few days, and that's about it. So if the design isn't optimized and ready to go at that time, there's not really any chance to turn back. And we're talking about teams with budgets of hundreds of millions of dollars invested here. And then overall success and failure of the design is going to be measured in fractions of a second. So every single result is crucial leading up to the on-track testing and the start of the season. So I won't spend too much more time going over slides here. I want to get straight into the demonstration. But we'll examine a few different flow scenarios, both internal and external. And we'll test multiple conceptual designs to see just how flexible and fast Discovery Live is. We'll also look at obtaining some relevant preliminary data Again, Discovery Live is intended for design exploration, not necessarily design validation. So we're never going to perfectly prove the concept in Discovery Live. That's not the idea here. That we're going to leave to the more traditional flagship solvers that Ansys has. Discovery Live, as I said, is intended to get a general idea of what's happening, make fast changes, figure out if that is the optimal path to follow. And then once your design is optimized and you think you have pretty much the final product, then you can head to the flagship solvers of Ansys and really validate the design and say with as much certainty as possible, yes, this is the way forward. Aside from that, I do want to mention here that we have the Ansys Discovery Community Forum. I'll mention that at the end of the presentation as well. But in that forum, we have over 500 knowledge articles on Discovery Live, Discovery Space Claim, Discovery AIM. We also cover installation and licensing, FAQs. These tips and tricks webinars are being recorded, and they will be available after the presentation there. And so that forum is moderated by Ansys experts. It has hundreds of free articles and videos and in-depth tutorials, and thousands of people from around the world are using it every day. So, without any further delay, let's get into Discovery Live. So the first example we'll take a look at here is going to be the automotive HVAC simulation. So this is an approximation of maybe a heating duct within your car, something that you may need to have some idea of how the flow is working. So this model we can start from scratch to create a solution. What I have here is the geometry, which could be created in Space Claim, or could also be created right here within the same context of Discovery Live. This is really the beauty of this product, is that all the tools of Space Claim are integrated here into your toolbar. So you could start a design from scratch and then seamlessly go into creating a solution to test how that design is going to perform. So this geometry was created beforehand, but I'm going to create my solution now just to give you an idea of how we can start this process. So down here at the center, we have a button that says Create Solution. We'll click here, and you can see the various different solutions that are available to you, which I mentioned earlier. We have thermal, we have fluid, structural, and modal. In this case, we're interested in fluid behavior. The object, or the fluid itself, is going to be air. And so I'm going to select to create a fluid volume, and here I'm going to select internal flow. A little bit later, we'll cover external flow. But for right now, we want to see what's happening inside of this HVAC system. So it is important to note up here, these are where your instructions are going to appear in the top left. Sometimes it's easy to miss, but it says click to select inlet faces or shift click to select capping faces. So inlet faces also is going to cover the exit or the outlet. Shift click for capping faces. If I have an opening that I don't wish any fluid to come out of, then I can cap that face using shift and click. So I'll left click here, that's my inlet, and then I'll come over here to the top of the model and I will left click there. So you can see that immediately we start to get some simulation results. That's really how quick this is. Normally, the appearance would be a little bit sort of rougher. I like to activate this smoothing or smooth color appearance down here from the legend. If we click that little color swatch, we'll smooth that out. So you can see it's very, very nice, really visually appealing, very pretty results. And right now what we're looking at is the velocity, and we're looking at the maximum value. So currently in our solution, by default, we selected air at room temperature, which is 20 degrees Celsius. The flow velocity is here. It's currently set to 0.5 meters per second. We can increase that if we want to. Maybe I'll set it to 1 meter per second. And so you can see that it begins to update nearly instantly. So there you can see our maximum velocity highlighted in red. Now we have a few other items that we can display. Primarily, there's a surface option that you can use, which that's better suited for areas where you might want to show a cross-section. In this case, it's not showing too much. The composite display style is really nice. It shows us a little bit more sort of the flow itself, but in kind of a 3D and much more mixed and colorful way, where you can sort of see these lines of flow extending through the model. These controls here allow you to sort of focus in on which particular velocities you want to show. The bandwidth actually controls how much is shown, and the center controls which area of this legend is being focused on. So you can see right now we have sort of some greens and blues. If I go to the left here, we're going to focus on the slowest velocities, and if I go all the way to the right, we'll focus on the highest velocities. And if I go all the way down, we can see almost the maximum area of velocity right there. So centering gives us about the middle. So we can see some red, we can see some yellow, and it kind of extends the range of this that's being shown. In any case, this composite display is very nice. Again, it looks nice here, but it also looks nice for external flow, which we'll see in a few minutes. Inverse surfaces is going to change the display characteristics. ISO will show us some various different areas of the flow like this. This works better for pressure, the pressure distribution. Maximum value is what we started off with, so we can kind of see where the maximum velocities are, and minimum value, which isn't so helpful in these cases. Now, as far as this result component, we can choose which component of the flow we want to visualize. So in this case, it's showing us a sum, which is all, X components, Y components, Z components. So you can see which one exactly is going where. Now, from there, we have other display options, so we can see the pressure distribution through here. Again, a lot of these same display styles also apply. So the flow is coming in through here. We'd expect the highest pressure to be up against this wall, and then kind of gradually diminishing as we go through the duct. The ISO surface, as I said, you can choose sort of which ISO value is being shown, high pressure, low pressure, and so on and so forth. So we'll go back to max value for that one. Temperature at the moment is constant. We could add from our setup panel over here some various temperatures on selected faces. If there's another component in here, we could add a temperature to that. And then last but not least, vortices. So vortices are showing us areas of the flow, vortices that are happening within the flow. This looks pretty cool. It also looks great for the external flow, which we'll see momentarily. So we'll go back to velocity in this case. And now we're going to really see some of the coolest aspects of this and areas where the functionality and flexibility of SpaceClaim really come into play. So what I have on the right-hand side here are my various different panels. The top one is the structure tree. Previously, I've defined a few different pieces of geometry to add in here. So the first would be a fin to alter the flow as it's moving through here. What we can see, as soon as I activate that, if I shut off these results, you can kind of see the fin inside there. But as you note, as soon as I turn that on, the volume of the airflow updated instantaneously. And so now we're continuing on with this analysis. I'm going to reset the simulation just so we can kind of get an idea of what's happening here. You can see the amount of time that has elapsed within the simulation from the legend. So, of course, it's going to be a little bit slower than real time, but you can see it here. So we're at about a quarter of a second, and we can see the flow sort of adjusting to that change. Other things that I can do are I can update the entire body itself if I need to extend it. And so in this case, I'm going to grab the two faces of that duct, and I'm going to use the move command. So that's still from within the SpaceClaim toolbar. We can select the move command and just click and drag to extend this out. I'm going to extend it out pretty far, and we'll see why in a minute. But as we do that, once again, you can see that the volume has updated and the simulation is updating as well, basically in real time. Now, from our structure tree, we have a few other items. Right? So we have a middle fin, which you can put a second fin in there, and you can see now that flow is updated as well. And last but not least, we'll put in that last fin. So this is the speed with which you can adjust, make changes, test out different concepts. It's really quite responsive, and you don't have to wait even minutes. We're seeing changes in seconds. So that's really the power here of Discovery Live. You're able to just jump in, make a model, define a solution, make some changes as necessary, and see which concept is working out the best. Once you have that information, you can move on. You can go to a different model. You can try a different concept. You can show this to a customer and say, hey, does this look like what you want? So the last piece of this demo here is this heat bar. As I mentioned, you can take and insert items and temperatures to control or investigate how the flow will change based on a temperature. So this is important, if you have two fluids mixing together, or for instance a heater like this, you want to know, okay, is the heater at some temperature going to be sufficient to get the flow of the fluid to the desired temperature? So with that heat bar in place, what we can do is we'll go to our setup. We'll set a temperature on selected face. So here again, the instructions: select faces or bodies, then click the complete tool to create the boundary condition. So I'm going to select the body from the menu here. And I'm going to apply a temperature in Celsius. Let's call it 40 degrees. Maybe a little higher. Let's call it 45. And we'll hit the check mark there. So the air was coming in initially at room temperature. If we go to our results display, we can set temperature, and we can view a composite display. We can view max value, and we'll see obviously that the heater has the maximum value. But we can also see how this is now traveling through the duct and where that warm air is going. Right? So the other thing that we can do is we can create a calculation to display, hey, exactly what is the temperature throughout this body. So if I go to this, sorry, let me back up a moment. This icon here is for the calculations, and we'll see a few more of these throughout the demo. I'm going to take a look at more here, and I'm going to select temperature. This component I don't think is relevant, but we'll take a look and see the value, and I want to find just the mean value throughout. And I'm going to select the face on this body. So we'll come over here. We'll find this face. Let me make sure that my volume is displayed. So that's the face, and so we can see the chart here displaying the mean value of the temperature. Now, if I collapse this chart down, it'll show me a value, which is a little bit easier to read than the chart itself. Later on, we'll take a look at some pretty cool stuff into how we can compare and contrast different configurations and get some values. So this, this simulation is still running. This value will continue to increase until it reaches a steady state. That is this flow. It's taking the average across this entire face. So as we can see, there's still some areas here that are not all uniformly at the same temperature. But eventually, as this simulation continues to run, if we let it run some time longer, I assume that we'll reach a steady state. And we're sort of converging here on temperature. The temperatures stopped increasing quite as quickly as it was before. So we're getting there. But that's essentially how you would achieve this type of a measurement or calculation. All right, so let's move on to the next example. These are some of my favorites in this case. So I'm not going to save this here. I'm going to close this out. And we'll take a look at this Formula One car. Now, this is just a model that I pulled off of the internet. It's not representative of the current design of a Formula One car, but it's close enough. So right away, we have a full car. This is a little bit different than just an HVAC duct. So questions may be, well, can Discovery Live handle something like this? And the answer is most certainly yes. So once again, I'll select air, and we'll create a fluid flow. In this case, it's going to be external. So I'm going to select Create, and I'll zoom out a little bit. It gives us a preliminary enclosure, and it asks us to select the inlet direction. So I'm going to select this as the inlet direction, and now select ground plane for the enclosure, so basically the road in this case. So that's my ground plane, and once again, we immediately start getting some results. Now, in this case, the results look good, right? They look pretty good, but we might want to pay some closer attention to some of our parameters here. The flow velocity is 10 meters per second, which is about 30 miles an hour, I think, which is extremely slow. So that's not really a respectable speed for a Formula One car. So we're going to crank this up to 75 meters per second, which is, I think, a little bit over 150 miles an hour, maybe slightly more. So now we see that update happening, in real time. The flow is going as we're moving along here, and so that's all well and good. However, this example, and I'll touch upon this a little bit more in depth in a minute, but it is something that I want to mention because we have to acknowledge the fact that Discovery Live has some limitations, and that is intentional, as I mentioned. The speed with which we're doing this comes at the cost of fidelity. And what does that mean? Well, what it means is that in certain aspects, Discovery Live is going to not perform as well, with certain models. In this case, we have a very relatively large car. And so we have a setting for fidelity here, and we can have our trade-off between speed and fidelity. Now, as you can see, we're about 2 seconds into the simulation time. The speed is we're on the speed side of this, not the fidelity side. So certain areas of this model may not be taken into account. What you'll notice here is this front wing is extremely thin compared to the overall size of the model. And so in those types of areas or those types of situations, you would increase the fidelity, or you may want to just test the front wing by itself. Because when Discovery Live looks at this entire model, it has to do so and take everything into account. And so in certain stages or certain times, it's going to not be able to quite make the adjustments necessary to take something so thin by comparison to the rest of the model into account. So those are things that you have to look out for, and we'll take a look at this a little bit closer in this upcoming example. But this looks great overall, right? If I go back to my display style and I show you composite, we can see the flow over the entire car. We'll come to this side. I'll tweak this bandwidth a bit, and you can see, right? That looks fantastic. Look at this. You can see the flow going over the wheels, over the tires, over the rear fin there, over the driver, and so you get a really good idea of what's going on. Also, this is not as beneficial for flow if you want to see exactly what's going on, but you can show the time average result display, which is going to smooth this out and kind of eliminate some of those heavy fluctuations that you may see. But in this case, for a car, you may want to see kind of what this turbulent flow is going to look like. Right? So that's all very cool. If you wanted to examine the cross-section here to see kind of exactly what's going on over the driver's head and so on, we can right-click and we'll say Clip with Plane and Clip, and there you can see, get a good idea of the cross-section and what's happening. If I go back to Surface, now you can get an idea of what's happening there. So that's all quite excellent. All right, so the next thing we'll do is we're going to take a look at a couple different design options that we have here. If I remove this clipping, the rear wing, you can see, is somewhat of an old-fashioned wing. This angle is currently set to 0 for reasons which we'll explore in a minute. But we can quickly swap in and out different components, as I showed you earlier. And so notice this. If I remove that new rear wing, this flow is updating, right? So boom, it disappears. Put the new rear wing in, and so we can see this right now. Now, the reason I like this example is for the following. As I mentioned, fidelity is an important aspect of your overall analysis. This wing has much thinner components than the previous wing. And as you can see, in this area, the flow is passing through. But we do have the option to increase the fidelity. It's going to slow down our results, but as we increase the fidelity, we'll see those results get better and better. So currently, we're at about halfway. If I go to the clipping plane, we can get a better idea of what's going on. But for this particular example, with the entire car in place, we're still going to need to increase the fidelity, and you can see exactly what's going on. So out of that portion of the wing, those bits and pieces there are what's getting picked up. As we increase the fidelity, we're going to see more and more of this wing get picked up. But again, this is something where you may want to leave out the rest of the car if all you're interested in is testing the wing. So we'll do that. I'm going to hide the car. We'll see the flow updating there. In fact, what I'll do in this case now is I'm going to pause this. Actually, we can edit the enclosure manually from here. So if I select Edit Enclosure, we'll just drag this in a little bit, and we'll let that enclosure update. In fact, I think I'm going to create a totally new enclosure for this, just to review that one more time. So we'll remove this enclosure. I'm just going to delete it. Our solution has now, has several warning messages, so I'm just going to delete that as well. This warns me about history being cleared. Oops. There we go. And once again, we'll zoom in on this. So we have now just the rear wing present, and the old wing is in there somewhere as well. So I'm going to go back to the old wing because I have a nice little example set up there, and I'm going to create another solution. So once again, external flow, create. You'll see that the enclosure now is much smaller than it was previously. And so we can see pretty much instantly the flow coming in here. All right, so once again, let's take a look at our flow velocity. We're going to increase this much faster. And we have a few things set up here that we can take a look at. I'm going to hide the enclosure now. We don't really need to see that. And I'll go to composite for my display here. Okay, so some very cool things that we can do in Discovery Live with obtaining data, because data is important to us, right? So we're engineers. We live by the numbers. If the numbers don't hold up, the design is questionable at best, right? So what can we do for that? Data collection. As I mentioned earlier, we have these calculations that I showed you with the temperature in the HVAC duct. So some of the most basic ones, we have forces on face in X direction. In racing terms, this we could call drag. Right? So we'll select some faces. I'm primarily going to be concerned with these faces here. So I'll double click and grab that set of faces. Here are our numbers, right? This is coming up. It's going to bounce around a bit because this is a transient analysis. So as I mentioned earlier, you might like to do time average result display, and that will sort of level out this plot a bit. Right? You can see it there. That's kind of taking the average. You can also highlight an area and get some results there. And of course, we can expand this to make it much larger and a little bit more legible. Right? So these are the time average result display, which evens this out. It's bouncing all over the place because of the airflow and everything else being transient, but the time average result works nicely for that. So that's drag. We'll make another calculation, equally as important for a race car, which is going to be downforce. And that's going to be the force in the Z direction, right? So vertically up and down. Faces, again, I'm going to select the same set of faces and hit OK. And so now we can see the downforce, which should be, we're looking at it to even out here, but it's going to be much less. It should be much less. So that's there. Now, other things that we can do with the tools here in SpaceClaim, or the SpaceClaim functions, are to create driving dimensions. So what I've done in this scenario is I selected this solid portion of the model. And I'm going to pause this analysis for a moment. I selected this solid portion of the model, and I used the move command to create a driving dimension. And so this angle I can control, and I can use the ruler option to measure the angle from some edge or face or plane. And in doing so, I can constantly update it manually from another selection and have it always have this reference angle as 0. So in this case, what I have is the ruler dimension over here, and you can see that I can tweak it by entering a value. So maybe I'll put in 10 degrees. And the wing will change its orientation. Now, if I show those results again, it should give me the updated results for the flow. Right, so there's that. We can restart that or update the volume. Now, why is this important? Well, if I undo that change, right, we can come back to our analysis. We can see it there. I'm going to go and show. I'm going to show this as a surface again. Right. What can we do with this? Well, we can create a parameter study, and this is going to be nice because it's sort of hands-off, kind of fire and forget. We can add a parameter. In this case, I'm going to select the driving dimension for the angle. And I can specify a starting value and an ending value. Right, so 25 degrees is going to be my ending value. The number of steps I'm going to keep as 5. Right? Once I do that, we can see that this is now going to iterate through the various different angles, well, from 0 to 25 in 5 steps. And then it's going to give me the results of these calculations for a set amount of time. So in this case, we have to specify an end time. At this speed, 0.1 seconds is pretty good. I'm going to remove that time average result. I'm going to pause this. And then I'm going to come over here, and I'm going to start this parameter study. So as I do that, you can see the angle. Right. The other thing that we'll notice is this screen is going to get a little cluttered here, so for that I apologize. But if we examine what's going on here, this one's much larger. Let me just shrink that down a bit. We can see exactly what's happening. So let me try to get everything situated here in a way that's visually legible. This is going to plot the various different points, right? But you can see the numbers coming out here. Right? So if we expand this, you can see the different tables and the different plot lines as we iterate through these different values. Now this is important, right? Because we can see exactly what's going on. So we can see the difference. Sorry about that. We can see the difference between the angle and the downforce. And at some point, sorry about that, at some point, we're going to find that there's a sweet spot. Right? A much higher downforce with not... So we'll see the difference between downforce and drag and be able to find an optimal range. And so this is important. We can walk away from this. We can just let it run, walk away, and we'll come back and we'll figure out what our results are and where we should be headed as far as our setting for the angle of the swing. So I'll let this run to complete the study. It's going to take another second or two. But overall, I think this is a really great set of results. It's a great option to have, and this is new for Discovery Live 19.2. This wasn't here previously, so this is actually pretty phenomenal because you're able to just perform this study, walk away from it, set everything, and then come back and you have results, and relatively quickly. I mean, we're talking about maybe the course of 3-4 minutes to run through 5 different configurations and get some useful data. So that's really the type of stuff that Discovery Live is going to offer for all the different types of simulations: structural, fluids, thermal, and modal. So once this finishes up, we'll take a look at one more example. And this is going to be an example that is going to cover more of a sort of a consumer car, roughly speaking. So here are our results. We can see the plots. Everything looks good. Right? We can find here that probably the best option is 12.5 degrees or somewhere in between there. Right? From 6 1/4, the drag increased, by maybe a little bit less than a factor of 3, but the downforce increased roughly a factor of 4 plus, nearly 5. We went up a little bit more, got some more downforce, but then at some point those gains started to taper off, especially here. So we got to like 18, almost 19 degrees for the angle of attack and 25. Right, got a substantial amount of drag. At this point, it's almost a ratio of 1 to 2. Right, so that's not necessarily something that we're looking for. So, with those results in hand, we can continue our design and hopefully find an optimal solution. All right. Now, the final example, I'm going to close this one, is going to be, this is a concept or a design that was recently released by one of the major high-end sports car manufacturers. And what it is essentially, this is the typical design. Right? So the typical design, typical hood, everything looks fine. Right? I'm going to move this up a little bit. I had defined some calculations ahead of time. And 45 meters per second, we're looking at roughly 100 miles per hour. And we can start this simulation here. So we can see the downforce, the drag, and kind of get an idea of where it's at. I'm gonna do the time average result display here, so we can have some idea now. This actually, yes, good. The downforce is there. The drag is over the entire body, but the downforce is just on these faces here. So we get some idea then of what's going on with the downforce, where it is. The fidelity, of course, we can toggle higher or lower, but in this case, it's fairly straightforward. Now, for the next example, or the updated model, here's what happened there. This was the classic design. The updated design has what's called an S-duct. Now, this S-duct is intended and designed to allow airflow to come in through the front here, where kind of the grill area is. In these cars, radiators tend to be, it's a rear engine or mid-engine design, so radiators tend to be in the back. The airflow into the radiator would come in, through, there's usually a duct over here for the intercoolers. And then there's some extra ducts around here to move the air around into the brakes and so on. But this is an inlet designed to take the airflow, allow it in and up and over the hood. Right? So that would reduce some drag and add some additional downforce. I think in the real world, the increase in drag due to this was about 2%, and the increase in downforce was about 20% over the traditional design. So fairly large increases with very little penalty. And for a performance sports car that may or may not end up on the track, those are fairly important numbers. All right, so let's take a look at this one. We'll begin the simulation and show our results. Now, actually, now that I think about it, I did want to create some calculations for this. So let's go to our grouping, I selected those faces ahead of time, and I'll insert a calculation. This is going to be force in the Z direction over the selected faces, select those, and say OK. And so now we can see how this is performing. So we can compare and contrast the two sets of values here. Okay. We're looking at this set of units should be in newtons, which it is, but as this increases, we'll need to divide by 1,000 to get our force in newtons. So we're at negative 1.4 times 10 to the 5th. And so if we divide that by 1,000, we end up with about 140 newtons and climbing. So that's what we're looking at here. And this is, I thought, a really cool example because it's fairly complex, the geometry, and we can get a really good idea and understand how our design is being affected overall. So once more, we could add the forces in the X direction, all faces of the body, select this body, and check mark, and then we can see the drag on this body as well as this is going. And we can toggle back and forth between the two. So maybe we'll jot this down, or we could also create some type of parameter study, perhaps, see what that next value is going to be, and then toggle back and forth between the two different designs. So that is more or less what I had for the presentation today. I hope that it's been informative and interesting and not too dull, but I think these topics and this product itself, Discovery Live, really lends itself to having some really fantastic results, and especially visually, of course, this looks great. So we'll open it up to some Q&A. So I assume that some of you have been posting questions within the chat. We'll continue to answer those for a few more minutes. And then for any of you who have additional questions or would like to examine Discovery Live or the other products, we have, as I mentioned, in our knowledge base here, sorry, let's get through these slides again. In the knowledge base, and I should put up the link here, or the URL, we have over 500 knowledge articles, demos, videos, and so on. From here in Discovery Live, we can go to the forum. Let's see, from the start page, if I select forum, that should take you directly to the forum. So in this case, the URL is discoveryforum.ansys.com. And this is what it looks like within the forum. We have tutorials, how-tos, application examples. If you'd like to search, you can search through here. You can ask a question. You can request a trial. So the forum itself has a lot of useful information. It's moderated by us, the Ansys staff, but also is open to public discussion. And so all of that really is available to you within this forum. So once again, discoveryforum.ansys.com. And you can see here the various different videos. So for instance, getting started with Discovery Live, we have introductions into the user interface, fluid simulation, structure simulation. All of these are videos here, created and narrated by us. So very useful set of links or videos there. All right, so that concludes the presentation for today. I'm going to just stop sharing my screen here, and then I will answer some questions through the chat.
Yeah, so thank you, Brian. And there actually don't seem to be any questions in the the Q&A chat at the moment. So, if people do have questions in the future, you can go to the Discovery Community Forum, as Brian said, and post your questions or look up answers that may have been previously resolved by the moderators. So make sure to do that. If there are no questions at all, thank you everyone for your attendance and participation in today's Tips and Tricks webinar. I hope to see you again for our next Fluid session on October 11th on Ansys Discovery Live Concept Optimization using Modal Analysis. And please be sure to also check out our other Tips and Tricks sessions on mechanical, electronics, and discovery topics on the Ansys events page. Thank you, and bye for now.